Hello everyone, myself Anil. Today I'm here to talk about software quality models, which is the topic of software engineering and project management. Abstract. The abstract of the paper is all about how the software quality is super important, and because we want software to be usable and reliable and just overall better. So research have come up with a bunch of different models to measure our software quality, and this paper is looking at some of the well-known ones like MC-Call, BOEM, and FURPS and ISO 9126. And what the study does, it compare these models based on these things like how easy the software is to maintain and how fast is work, and how it is reliable, and if people can use it easily, and they use the math to do the comparison to make it clear and precious. And what they found is that the each model has its own strength and weakness, and they talk about the how the result can help to improve the future models for checking the software quality. Introduction. Now for the introduction, it's basically saying that all the software quality is a really big deal, because if the software isn't good, and it's not going to be hard to maintain, and people won't like using the over the years, people have come up with a different models to try and measure this quality. And MC Call's model has was one of the first to do the focusing on the reliability and usability and maintainability, and then the other models like BOEMs or FURPS, which are added more factors and made better ways to measure the quality. And as the software got more complicated, and these models had to change to keep up the different types of software and industries. But the problem is these models don't define the software quality in the exact same way, which makes it tough to compare them. So this paper is trying to fix that all by coming up with a method to compare them more clearly. Methodology. For the methodology section, what they did was they picked the four models, which are MC Call and BOEM, FERPS, and ISO 9126. These are the four models, and they compared them using the mathematical method, where they break down the each model into a smaller parts like different factors, and each model looks at their way the how important each factor is, and then assign the values to them. The expert in the software quality were the ones who gave the weights and to the things like usability, efficiency, and maintainability. And the math they used made sure that the small details were included in the comparison, so they could get a full picture of each model's strengths and weaknesses. And they showed the result using the graphs to make it easier and to understand. Then the result part. The result showed that there were big differences between the models. For example, MC Call's model was really good in terms of integrity and usability and probability, but it does not focus on on the functionality. And the BOEM's model was strong in maintainability, but did not pay much attention in the user side. And the FERPS was focused on the things like usability and performance, but it did not cover the maintainability and probability. As much as the ISO 9126 had the six main characteristics like functionality and efficiency, but it left with the important things like reusability and human engineering. So what this all means is that no signal model covers every part of the software quality perfectly. This is the model weighting graph. The discussion part. The discussion talks about how these findings show that we are really need more integrated approach to software qualities, and because while each model has a good points, none of them are complete enough on their own. So MC calls model is good starting point and evaluating the internal and external quality, but it's limited. It's limited, and BOMs and FEPRS models are better in that covering the like usability and maintainability, but they miss out on the important factors of the method they used. The comparison was useful, and because it gave a way to see how much each model covered are the different quality factors in a measurable way. And it's also brings the questions how well these models works for the modern software development, which might need more flexible and in the real time evaluation methods in the future. This is the result and discussion graph. Model comparison between the result and discussion graph. Let's see the conclusion. Finally, the conclusion is it says that the study has shown the strength and weaknesses of the major software quality models and gives a good idea of when and where each model can be useful, like MC calls and BOMs. These are the models where they are useful, are still in the really influential, but they did not cover everything, while FURPS and ISO are user focused and they covered almost all the points, but also have some graphs, and the mathematical method they used was helpful in showing the differences and suggestions and the improvements. But in the end, there is no perfect model for evaluating the software quality, so the future models need to take best part of these and combine them to be more and complete. And they also mentioned that the future work should try to refine these models, maybe by making them fit better for specific type of software or making them more dynamic. Thank you for watching this video. Thank you.